Okay, in this last video for chapter 12, and I pulled these questions from different textbooks, so just ignore that. So for this last video, let's just do some problems to illustrate some of the concepts you have to sort of keep track of when you're dealing with this topic. Now, one thing I'll say is, and I won't even get into it in this last one, that type of problem we won't do. And like for us, if you look back at the discussion either in the first video of this set or in the lecture videos, one of the key features about dispersion forces is that, dispersion forces, we say, are proportional to the molar mass of the molecule. So really, I mean, if you want to know which one has a stronger intermolecular force, then what you're really asking is just simply which one has the higher molar mass. If you look on the periodic table, bromine has a large atomic weight. You put two of them together, and that's going to have the larger molar mass. For this compound, these two compounds here, and don't get distracted by the way some of these molecules are presented to you. Think about what we know. We know that, we know that's carbon, we know that hydrogen, we know there's 3 hydrogens there. And notice then 2 hydrogens, and so there's like this repeating pattern of these carbon-hydrogen groups attached to something that's called a thiol. It doesn't really matter. SH sitting here. How many carbons? 1, 2, 3, 4. So this is the 4th carbon versus 1, 2, 3, 4, 5. This one has the larger molar mass. It has a greater dispersion force. And that's it. This key concept is really important when you're trying to drill down and find out something about dispersion forces. Now, something else that I can say about these two molecules. So yes, they have the higher molar mass. Yes, they have higher or stronger dispersion forces. And then they also have higher melting point and higher boiling point. All these things just go hand in hand together. Let's look at A for this one. This problem is asking just for a specific intermolecular force. Fine. I'm actually going to use this example just as sort of, I'll answer the question, but I actually want to take, a couple of these. I'm not going to do all of them, and just sort of expand on, how to think about and how to interpret this kind of information. So let's just look at A real quick. And so we're looking at something called methanol, and this other one is methane thiol. Names aren't important here. And what I notice is that the methanol has a much higher boiling point than this thiol compound. Well, one thing to note, so higher boiling point means that it has stronger intermolecular forces. Now, the one that's jumping out at me here is the fact that I'm looking at an OH group on the molecule. That means it's a hydrogen bond that's causing this greater intermolecular force and the higher boiling point. It's the answer to this question. The other one I want to do is this last one. Now, one issue here is, so you don't need to know the nomenclature for organic compounds. I would give you the two structures. So acetone has this molecule, or has this structural formula, or Lewis structure, if you want to call it that, it's fine. And then 2-methylpropane has this compound, has this look to it. And we see acetone boils at, so let's see, boiling point is 56 degrees Celsius versus this one's minus 12 degrees Celsius. So it's not even a liquid at room temperature. And again, just want to make a note, same thing I did here. So if it has that higher boiling point, that means it has a stronger intermolecular force. And then which intermolecular force are we talking about? Well, if I look at this one over here, if you look back, if you watch the first video, the test review, then this is a hydrocarbon. And again, something I said there, if you are presented a molecule in whatever form, however it looks, and the only 2 atoms you see in it are hydrogen and carbon, it is a hydrocarbon. And hydrocarbons are nonpolar. What does that mean in the context of intermolecular forces? Then it only has dispersion forces. Remember, dispersion forces, all molecules have dispersion forces. So, for example, this one definitely has dispersion forces, yes. And I could have said the same thing here, I just didn't. I'll do it now. All molecules have dispersion forces. Like this methanol has dispersion forces and hydrogen bond. 2-methylpropane only has dispersion force. Acetone has dispersion force, and then it also has, right, if it has that electronegative atom in it, it's polar. If something is polar, there's two possibilities. It has dipole-dipole or hydrogen bonding. Now, it doesn't have hydrogen bonding because it doesn't have this OH feature, but since it has electronegative atom in there, then it does have the dipole-dipole intermolecular force. 2 are stronger than 1, so it's really the dipole-dipole intermolecular force that accounts for the larger boiling point in this compound. And the last thing I want to say about this particular problem is the fact that both of these have about the same molar mass. So the dispersion forces in each are approximately equal. So like the total intermolecular force caused by dispersion forces here and the intermolecular forces caused by dispersion forces there, the magnitudes are essentially the same because they have the same molar mass, or something very close to the same molar mass. So again, the only thing to account for the higher boiling point here is that extra intermolecular force in acetone. And that'll do it for the Chapter 12 review. Thanks.